Question 1. From the perspective of Lee, who is commissioning a newly installed closed-loop hydronic heating system, he notices that the system pressure fluctuates significantly during operation, causing inconsistent flow rates. Which of the following is the most likely cause, and what should Lee do to address it? A. The expansion tank is undersized. Lee should replace it with a larger volume tank. B. The pump impeller is worn out. Lee should replace the pump impeller. C. The system contains air pockets. Lee should perform proper air elimination and purging procedures. D. The boiler control settings are incorrect. Lee should recalibrate the aquastat controls. Answer. Correct answer. C. Explanation. Fluctuating pressure and inconsistent flow in a closed-loop hydronic system are frequently caused by trapped air pockets disrupting water flow and causing pressure surges. Proper air elimination via vent valves and purging ensures stable pressure and flow. An undersized expansion tank can cause pressure increases, but not typical fluctuation or inconsistent flow. Worn impellers reduce flow, but don't usually. Pressure swings. Incorrect aquastat settings affect temperature, but not hydraulic pressure stability. Air removal is fundamental for system balance and preventing noise, cavitation, and corrosion, aligning with hydronic maintenance best practices. Question 2. Considering the evidence, a technician is asked to select a pump for a hydronic system requiring a flow rate of 4 GPM with a total dynamic head of 60 feet. The pump curve indicates that the pump operates best at 45 GPM and 55 feet head. What should the technician do to ensure optimal system performance? A. Choose a pump with a maximum flow rating of 4 GPM and head of 60 feet. B. Select the pump with 45 GPM at 55 feet head and install a variable speed drive to adjust flow. C. Select a larger pump with a flow rating of 6 GPM at 60 feet head to ensure capacity. D. Choose a pump with 30 GPM flow and 70 feet head to avoid cavitation. Answer. Correct answer. D. Explanation. Selecting a pump with too high flow can cause system inefficiencies and noise, while undersized pumps cannot meet demand. Cavitation occurs where pH available is less than required, often due to low pressure on suction side. A pump rated below system requirements like 30 GPM at 70 feet is insufficient. The best practice is to select a pump that closely matches the design flow and head, ideally allowing adjustments like a variable speed drive to optimize performance dynamically. However, option D, 30 GPM 70 feet, is incorrect as it's undersized, making option B the better approach. The technician must balance flow, head, and adjustability. Question 3. Based on the information Isis Patel is designing, a hydronic heating system for a commercial building that requires zoning for 3 distinct areas with different heating demands. Which system design approach should she prioritize for best energy efficiency and control? A. Use a single large boiler with 3 separate pumps for each zone. B. Implement a primary-secondary loop system with zone valves controlling flow to each zone. C. Install 3 independent closed-loop systems with individual boilers for each zone. D. Use an open-loop system with mixing valves to regulate temperature in each zone. Answer. Correct answer. B. Explanation. A primary-secondary loop design enables a single boiler to supply constant flow in the primary loop, while secondary loops with zone valves or pumps adjust flow independently to each zone, optimizing energy use and comfort. Using multiple boilers is expensive and complex. An open-loop system is generally not suitable for commercial heating due to contamination risks and inefficiency. Separate pumps for zone without primary-secondary piping can cause flow interference and inefficiency. The primary-secondary approach improves hydraulic separation, energy efficiency, and simplifies control. Question 4. When faced with a hydronic system exhibiting signs of cavitation, noise near the pump suction, which of the following actions should a technician take first to correct the problem? A. Increase the pump speed to overcome suction losses. B. Check and increase the net positive suction head available in pusher by raising the supply tank level. C. Replace the pump with a higher horsepower unit. D. Install a larger diameter discharge pipe to reduce pressure losses. Answer. Correct answer. C. Explanation. Cavitation occurs when the pressure at the pump suction drops below the vapor pressure of the fluid. causing vapor bubbles and damage. Increasing pump speed exacerbates cavitation. Increasing in pressure by raising the supply tank level is a common corrective method. Replacing the pump with a higher horsepower unit without addressing any shell does not solve the root cause. Larger discharge pipes reduce pressure losses downstream, do not affect suction conditions. Thus, increasing in pressure by raising supply tank or lowering pump elevation is the first step. Question 5. Among the various hydronic fluids, which property most significantly affects the heat transfer efficiency within a closed-loop system? A. Density of the fluid. B. Specific heat capacity of the fluid. C. Viscosity of the fluid. D. Boiling point of the fluid. Answer. Correct answer, B. Explanation. Specific heat capacity determines how much heat energy the fluid can absorb and transport per unit mass, directly impacting heat transfer efficiency. Higher specific heat means more heat can be moved with less fluid volume. Density affects mass flow, but less than specific heat. Viscosity impacts pumping power required, but not heat capacity. Boiling point relates to system operating temperature limits, but heat transfer efficiency in typical hydronic ranges. Thus, selecting fluids with appropriate specific heat ensures optimal thermal performance. Question 6. Given the circumstances, Mr. Gomez observes that a newly installed expansion tank frequently loses pressure, causing system pressure fluctuations. What is the most likely underlying cause and what action should be taken? A. The tank diaphragm is ruptured. Replace the expansion tank. B. The system water contains air. Bleed the system thoroughly. C. The boiler relief valve is faulty. Replace it. D. The tank is oversized. Reduce its volume. Answer. Correct answer. A. Explanation. A ruptured diaphragm causes the expansion tank to lose its ability to absorb volume changes, resulting in pressure fluctuations. Air presence causes pressure spikes, but not recurring pressure loss inside the tank. A faulty relief valve causes pressure relief, but doesn't affect expansion tank pressure retention. Oversized tanks do not cause pressure loss, and they generally improve stability. Proper diagnosis confirms diaphragm failure, necessitating replacement for system pressure stability and safety. Question 7. In the context of a technician troubleshooting an uneven heat distribution in a zoned hydronic system, what is the most likely cause and best corrective action? A. Zone valves are partially closed or stuck. Inspect and repair or replace affected valves. B. The boiler is not producing sufficient heat. Increase the boiler temperature settings. C. Pump impeller is clogged. Clean or replace the pump impeller. The pipes are incorrectly sized. Replace with larger diameter pipes. Answer. Correct answer, D. Explanation. Uneven heat distribution is often caused by improper flow rates due to incorrect pipe sizing or flow restrictions. While stuck zone valves can cause no flow to zones, uneven distribution is more systemic. Insufficient boiler temperature affects overall heat output but not distribution balance. A clogged impeller reduces total flow, not zone-to-zone balance. Proper pipe sizing ensures adequate and balance, minimizing pressure drops and ensuring zones receive designed heating, which is essential for comfort and efficiency. Question 8. Throughout the course of a preventive maintenance inspection on a hydronic system, a technician finds excessive scale buildup inside the boiler heat exchanger. What is the best explanation for this condition and what steps should be taken? A. The system water has high hardness. Implement water treatment and chemical descaling. B. The boiler is operating at too low a temperature increase set point. C. The expansion tank is undersized. Replace with larger capacity. D. The pump flow rate is too high. Reduce pump speed. Answer. Correct answer, B. Explanation. Scale buildup is primarily caused by mineral precipitation from hard water and excessive temperatures that cause dissolved minerals to crystallize. While high hardness requires water treatment and descaling, low boiler temperatures do not cause scale. Rather, high temperatures accelerate scale formation. Expansion tank size and pump flow do not directly influence scale formation. Thus, the technician should focus on treatment and maintaining proper boiler temperature to prevent scaling and extend equipment life. Question 9. In light of recent developments, an HVACR technician is tasked with optimizing the controls of a hydronic heating system with multiple zones. Which approach is most effective for balancing system performance and energy savings? A. Installing individual thermostats with zone valves controlled by an acostat on each zone. B. Using a single thermostat for the entire system to simplify controls. C. Installing manual valves for each zone to adjust flow manually. D. Utilizing a building automation system with variable speed pumps and integrated zone control. Answer. Correct answer. A. Explanation. Individual thermostats combined with zone valves and acostats allow precise control of heating demand per zone, reducing energy waste by only heating occupied areas. A single thermostat lacks zone control, causing inefficiencies. Manual valves cannot dynamically respond to temperature changes. Building automation systems provide advanced control but are more complex and costly. Option A balances efficiency and practicality for most hydronic applications. Question 10. Taking into account a hydronic heating system with multiple pumps arranged in parallel, Mr. Rogers notices excessive noise and vibration during operation. Which is the most likely cause and best corrective action? A. Pumps are operating at too low flow rates. Increase system demand to raise flow. B. Pumps are not synchronized properly. Install variable frequency drives for coordinated control. C. Pipe supports are inadequate. Reinforce piping and isolate pumps with vibration dampeners. D. Pumps are oversized. Replace with smaller pumps. Answer. Correct answer. B. Explanation. Parallel pumps require coordinated operation to prevent hydraulic interference causing noise and vibration. Variable frequency drives can synchronize pump speeds to balance flow and reduce mechanical stress. Low flow rates cause cavitation but not necessarily noise from multiple pumps. Poor pipe support can contribute to vibration but is secondary. Oversized pumps may waste energy but do not cause synchronization noise. Proper pump control improves system reliability and reduces maintenance. Question 11. Under the assumption that Rivera is diagnosing a hydronic system where the pump motor frequently overheats despite normal voltage supply, what is the most probable cause and what corrective action should she take? A. The pump shaft is misaligned. Realign the pump shaft and motor. B. The system pressure is too low. Increase system pressure via the expansion tank. C. The impeller is partially clogged. Clean or replace the impeller. D. The thermostat is malfunctioning. Replace the thermostat. Answer. Correct answer. A. Explanation. Motor overheating despite normal voltage often results from mechanical issues like pump shaft misalignment causing excessive friction and load. Low system pressure affects flow but does not directly cause motor overheating. A clogged impeller reduces flow and motor load, possibly causing underloading rather than overheating. Thermostat malfunction affects temperature control, unrelated to motor condition. Proper shaft alignment is crucial for pump efficiency and motor longevity as misalignment leads to vibration, bearing wear, and heat buildup. Question 12. By evaluating Mr. Kim's installation of an open-loop hydronic heating system, it is found that the system is subject to contamination and corrosion. What is the best solution to improve system longevity? A. Replace the open loop with closed-loop system and install suitable heat exchanger. B. Increase water flow velocity to reduce sedimentation. C. Add chemical inhibitors to the existing system without hardware change. D. Flush the system weekly to remove contaminants. Answer. Correct answer. C. Explanation. Open-loop systems draw water directly from external sources, increasing contamination and corrosion risk, while replacing with a closed loop is ideal. Adding chemical inhibitors can be an immediate, cost-effective measure to prevent corrosion and scaling. Increasing flow velocity can reduce sediment but may cause erosion. Weekly flushing is labor-intensive and does not prevent contamination ingress. Chemical treatment is a step. Approach per water treatment guidelines to prolong system life while planning hardware upgrades. Question 13. When analyzing a hydronic heating system using glycol-based fluids, what primary property change must be considered when selecting pipe sizing compared to using pure water? A. Increased density requiring thicker pipe walls. B. Higher viscosity leading to increased pressure drop and reduced flow rate. C. Lower specific heat capacity affecting heat transfer rate. D. Higher boiling point allowing higher system temperature. Answer. Correct answer, D. Explanation. Glycol fluids have a higher boiling point than water, enabling systems to operate at elevated temperatures without vapor formation. Density and viscosity do increase but do not typically require thicker pipe walls. A pressure drop increases due to viscosity must be accounted for, but pipe size changes depend more on flow and velocity limits. Specific heat capacity decreases slightly but does not mandate size changes. Understanding boiling point changes influences safety, pressure ratings, and system temperature design. Question 14. In terms of pump selection for a hydronic system, which factor is most critical to ensure the pump operates within its best efficiency point? A. Matching pump head to the maximum system static head. B. Selecting a pump with a flow rate near system design flow and corresponding head. C. Choosing a pump with the highest possible horsepower rating. D. Ensuring the pump impeller is the largest size available. Answer. Correct answer, B. Explanation. The BEP is the flow and head at which the pump operates most efficiently, minimizing wear and energy consumption. Selecting a pump near the design flow and corresponding head ensures optimal operation. Matching static head only ignores friction losses and varying system demand. Highest horsepower or largest impeller sizes may exceed system requirements, causing inefficiency and premature failure. Correct pump size, essential to hydronic system performance and longevity. Question 15. From a practical standpoint, a technician discovers the boiler water temperature frequently exceeds set point despite functioning aquastats, which is the most likely cause. A. Thermostat placement causing inaccurate temperature readings. B. Expansion tank volume is too large. C. Boiler relief valve is stuck closed. D. Circulator pump is running continuously causing overcirculation. Answer. Correct answer, C. Explanation. A stuck closed relief valve can cause pressure buildup, potentially leading to overheating due to trapped steam or lack of pressure relief. Thermostat placement affects zone comfort but not boiler temperature control. Expansion tank size affects pressure fluctuations but not temperature directly. Continuous pump operation can cause system imbalance but does not cause temperature exceedance if aquastats work correctly. Relief function is critical for safety and proper temperature control. Question 16. As illustrated by a hydronic system with multiple zones controlled by zone valves, what is the primary hydraulic advantage of using a variable speed pump in the primary loop? A. It maintains constant pressure regardless of flow demand changes. B. It reduces power consumption by matching pump speed to system demand. C. It eliminates the need for expansion tanks. D. It increases flow rate beyond design parameters during peak demand. Answer. Correct answer, D. Explanation. Variable speed pumps adjust flow and head to meet system demand, improving energy efficiency by reducing speed when demand is low, reducing power use. They maintain variable, not constant, pressure. They do not eliminate expansion tanks, which accommodate volume changes. Increasing flow beyond design can cause noise and damage. The correct use optimizes but does not exceed parameters. The main benefit is energy savings and improved control, not unlimited capacity. Question 17. Given the circumstances, Mr. Smith finds that after installing new piping in an existing hydronic system, the pump starts cavitating. What could be the primary reason and best corrective step? A. New piping has increased friction losses, reducing NPSH available. Increased pipe diameter on suction side. B. Expansion tank size is too large, causing pressure instability. C. The new pipes have trapped air, causing vapor pockets. They purge the system. D. The boiler temperature set point is too low, increased temperature to prevent vapor formation. Answer. Correct answer, A. Explanation. Increased friction losses in the suction piping reduce net positive suction head available in pusher, causing cavitation at the pump. Increasing pipe diameter reduces friction and improves in pusher. Expansion tank size is unrelated to suction pressure. Trapped air causes noise, but cavitation relates to vapor pressure conditions. Boiler temperature does not directly impact cavitation on suction. Proper suction pipe design critical to prevent cavitation and pump damage. Question 18. In what ways can proper pipe sizing negatively impact the balancing and efficiency of a hydronic heating system? A. Oversized pipes increase flow velocity causing noise and erosion. B. Undersized pipes cause excessive pressure drop and reduce flow to zones. C. Incorrect pipe length causes cavitation in the pump. D. Pipe size too small increase system water volume unnecessarily. Answer. Correct answer. B. Explanation. Undersized pipes create excessive friction losses leading to higher pressure drops, limiting flow to certain zones and causing imbalance and poor heating distribution. Oversized pipes reduce velocity and pressure drop but increase cost and space, rarely causing noise. Cavitation relates to pump suction conditions, not pipe length. Larger pipes reduce water velocity and system pressure drop, but they do not increase volume unnecessarily as volume depends primarily on length and diameter combined. Correct pipe sizing optimizes flow and efficiency. Question 19. To what degree does the use of thermostatic mixing valves improve safety and system performance in domestic hot water hydronic systems? A. They prevent scalding by limiting water temperature at the point of use. B. They eliminate the need for expansion tanks by controlling pressure. C. They increase boiler efficiency by recycling cooled water. D. They reduce pump wear by limiting flow rate. Answer. Correct answer. A. Explanation. Thermostatic mixing valves blend hot and cold water to deliver safe temperatures, preventing scald injuries, especially critical in domestic hot water systems. They do not influence expansion tanks or system pressure. While they contribute to comfort and safety, they do not directly affect boiler efficiency or pump wear. Their primary role is temperature control for user safety and system compliance with plumbing codes. Question 20. While examining the effects of water treatment in hydronic systems, what is the most significant risk of neglecting proper treatment in a closed-loop system? A. Increased risk of microbial growth causing odor and clogging. B. Reduced water pressure causing pump cavitation. C. Excessive expansion tank cycling causing pressure fluctuations. D. Faster heat exchanger failure due to corrosion and scaling. Answer. Correct answer. D. Explanation. Without proper water treatment, corrosion and scaling damage components like heat exchangers and piping, reducing heat transfer efficiency and causing premature failure. Microbial growth is less common in closed-loop systems due to lack of oxygen but can still occur. Reduced pressure and expansion tank cycling are more related to mechanical and hydraulic issues, not directly water treatment. Proper chemical treatment is critical for system longevity and operational efficiency. Question 21. Through the lens of a hydronic technician, Mr. Davis encounters an older boiler system that frequently trips the pressure relief valve during operation. What is the most likely root cause and proper remedy? A. Expansion tank pre-charge pressure is too high, reduce the pre-charge pressure. B. System pressure is exceeding design limits due to thermal expansion. Check and size the expansion tank correctly. C. The relief valve is faulty and stuck open. Replace the relief valve. D. The pump is cycling on and off too rapidly. Install a larger pump. Answer. Correct answer. B. Explanation. Thermal expansion in hydronic systems causes increased pressure. If the expansion tank is undersized or faulty, pressure exceeds design limits and trips the relief valve. Proper sizing and maintenance of the expansion tank accommodate volume changes and stabilize pressure. Incorrect pre-charge pressure causes pressure fluctuations but not necessarily relief valve tripping. A stuck relief valve causes leakage, not tripping. Pump cycling does not affect system pressure directly. Question 22. When considering hydronic system controls, what is the primary advantage of using outdoor reset control for the boiler operation? A. It improves system efficiency by modulating boiler temperature based on outdoor temperature. B. It reduces pump wear by cycling the circulator only when outdoor temperature exceeds a set point. C. It eliminates the need for zone valves by controlling flow directly. D. It maintains a constant system pressure regardless of load. Answer. Correct answer. C. Explanation. Outdoor reset control adjusts boiler water temperature based on outdoor conditions, improving efficiency and comfort by reducing unnecessary overheating. It does not directly affect pump wear or eliminate the need for zone valves. Zone valves control flow distribution to zones independently. It also does not control system pressure. Therefore, the main advantage is improved efficiency and comfort by matching heat out. Question 23. Considering the evidence is new and is designing pipe sizing for a new hydronic heating installation, which factor is most critical to avoid excessive noise and erosion in the piping? A. Selecting pipe diameter to keep water velocity below recommended limits. B. Using pipes with thicker walls to reduce vibration. C. Increasing boiler temperature to reduce fluid viscosity. D. Installing air vents at pipe elbows. Answer. Correct answer, A. Explanation. Water velocity directly affects noise and erosion potential. Exceeding recommended velocity limits causes turbulence, noise, and pipe wear. Selecting proper pipe diameter to control velocity is essential. Thicker walls reduce vibration but do not prevent erosion. Boiler temperature affects fluid properties but does not directly impact noise or erosion. Air vents prevent air buildup but don't affect flow velocity. Question 24. Among the various maintenance tasks, which procedure best prevents boiler lockout due to low water pressure? A. Regularly checking and refilling the system water via the feed valve. B. Periodically flushing the expansion tank to remove debris. C. Replacing aquastats annually. D. Increasing the pump speed to improve circulation. Answer. Correct answer, D. Explanation. Boiler lockout from low water pressure typically results from water loss or feed system failure, so regularly checking and refilling system water is the most direct preventive action. Flushing expansion tanks and replacing aquastats are maintenance tasks but do not prevent low water pressure lockouts. Increasing pump speed cannot compensate for lost water or pressure and may cause damage. Proper water maintenance is Question 25. For the purpose of hydronic system balancing, which technique best ensures uniform flow distribution across all zones? A. Using balancing valves to manually adjust flow rates in each zone. B. Increasing boiler output to force flow through all zones. C. Installing larger diameter pipes for all zones. D. Running circulator pumps at maximum speed continuously. Answer. Correct answer, A. Explanation. Balancing valves allow manual flow regulation to ensure each zone receives the designed flow, critical for even heat distribution and efficiency. Increasing boiler output doesn't guarantee balanced flow. Larger pipes reduce velocity but don't ensure balance. Running pumps at maximum speed wastes energy and can cause noise and uneven distribution. Manual balancing remains standard best practice. Question 26. In the modern context of hydronic pumping, what is the primary benefit of installing a variable frequency drive (VFD) hour system pump? A. Reducing energy consumption by matching pump speed to load demand. B. Eliminating the need for expansion tanks in the system. C. Increasing the maximum pressure head the pump can deliver. D. Simplifying pump maintenance schedules. Answer. Correct answer, B. Explanation. VFDs primarily reduce energy use by adjusting pump speed to system demand, lowering power consumption, and where they do not eliminate expansion tanks, which are needed for volume change. VFDs do not increase maximum pump head beyond design limits and don't inherently simplify maintenance schedules. Energy efficiency gains are the main advantage. Question 27. Given the circumstances, a hydronic system shows repeated premature failure of circulation pumps. What is the most likely cause and solution? A. Cavitation due to insufficient need to redesign suction piping and raise supply tank. B. Overheating caused by too large an expansion tank, replace with a smaller tank. C. Incorrect water treatment causing corrosion. Switch to distilled water. D. Excessive air in the system. Install additional air vents. Answer. Correct answer, C. Explanation. Improper water treatment causes corrosion, damaging pump components and shortening life. Switching to distilled water is impractical. A proper chemical treatment is necessary. Cavitation damages pumps but relates to suction conditions, not water chemistry. Expansion tank size affects pressure but not pump life directly. Air vents help, but corrosion is the leading cause of premature failure. Question 20. To illustrate this point, Mr. Johnson is troubleshooting a hydronic heating system where the heat exchanger shows signs of thermal stress cracking. Which of the following is most likely causing this issue? A. Rapid temperature cycling due to poor system control settings. B. Inadequate water pressure in the system. C. Excessive flow rates causing vibration damage. D. Improper pipe insulation causing heat loss. Answer. Correct answer, D. Explanation. Thermal stress cracking occurs when differential expansion happens, often due to heat loss and uneven temperature distribution caused by poor insulation. Rapid cycling causes wear, but usually not cracking. Water pressure impacts flow, but not thermal stresses directly. Excessive flow can cause vibration, but cracking is primarily thermal. Proper insulation reduces temperature gradients and stress. Question 29. The fundamental question is, in a hydronic system, why is it critical to maintain system water pH within recommended limits? A. To minimize corrosion and scale buildup, preserving system components. B. To increase water velocity for better heat transfer. C. To stabilize expansion tank pressure. D. To improve pump efficiency. Answer. Correct answer. A. Explanation. Maintaining proper pH prevents corrosion, acidic conditions, and scale alkaline conditions, both of which degrade pipes, boilers, and pumps. pH does not directly affect water velocity or expansion tank pressure, while pump efficiency can be affected by deposits. pH primary role is chemical balance to protect system longevity. Question 30. Upon closer examination, a technician notes that a hydronic system's circulator pump runs continuously even when zones call for no heat. What control failure is most likely responsible? A. Faulty zone valve failing to close, causing continuous flow demand. B. Boiler aquostat set too low, preventing pump shutoff. C. Expansion tank failure causing pressure spikes. D. Incorrect pump sizing resulting in continuous operation. Answer. Correct answer, A. Explanation. If zone valves fail to close, the system still demands flow, causing the pump to run continuously. Aquostats control boiler temperature, not pump operation. Expansion tank failure affects pressure but not pump run time directly. Incorrect pump sizing does not force continuous running. Ensuring zone valves operate correctly is essential for control and energy efficiency.